Okay, good morning, everybody. Um, Today is Thursday, the 18th of February. We are having our snow day today. So, what I'm going to do, and this isn't going to be a very good replacement for what we would have done in class today, but at least we'll get something done. So when we come back tomorrow, we'll be able to kind of get caught up. Um, so anyhow, I'm going to open my third marking period folder. I'm going to go to week 6, which is today, or excuse me, which is this week. And then, of course, I'm going to click on the 18th, and I'm going to grab the in-class folder. Okay, so inside the in-class folder, we have a couple different files, some links. Um, there is a PDF there. It says Liquids Notes. You're going to want to grab that and move that over to Notability. Okay, there are also a couple links to videos. After I go through the notes with you in this video, I'd like you to watch those videos. There are several demonstrations that go along with this lecture and these notes that we're taking that I would have done in class that are going to be really impossible for me to duplicate here. So I'm just going to pretty much go through the notes and give them to you. Tomorrow when we get to class, I will have the demos that we can look at and talk about some of the concepts that we're going to go through today. But today's lesson is about liquids. Um, And just remember those video links are there so you can come back and watch the viscosity video and the properties of liquids videos. Okay. All right, so I'm going to go over to Notability. I've already put the PDF into my Notability, and this is it. It's the behavior of liquids notes. So yesterday in class, we talked about gases, how gases exert pressure on the walls of their container. We talked about Boyle's law and how pressure and the volume of a gas are related. And we also talked about something called Charles' law, which describes the relationship between temperature of a gas and its volume. Okay, today we're going to turn to liquids. And if you think about liquids compared to gases, liquids represent a state of matter where the particles are not moving quite as energetically as they do in a gas. They lose some energy and they're no longer free from one another, so to speak. In a liquid, there is still something between the molecules or the atoms known as cohesion. Okay, and cohesion is simply defined as a force of attraction between the particles of a liquid. Okay, cohesion is the force of attraction between the particles of a liquid. I probably should have mentioned, if you have the ability to print this behavior of liquids notes sheet out and have a hard copy of it, that would be better than doing it in Notability on your iPads, because I do want you eventually, and we'll do this tomorrow if we have to, but I do want you to have a hard copy of this in your binders, these notes right here. So if you can print it out and write on those as we do it, that would be the best thing to do. If you can only do it in Notability, then so be it. We can take care of that later. Anyhow, back to liquids. Okay, so particles of a liquid, although they do have some freedom of movement, they can slide between one another and slide around, which allows liquids to kind of behave like they do, be pourable and all that kind of stuff. The particles still attract to each other. A couple of the ways we see this when we see liquids in nature is the fact that liquids form droplets. Okay. Rain falls out of the sky in a droplet. And obviously, if those droplets, which contain millions of water molecules, are falling in a big bunch like that, they must be holding each other. Now, this force is not unbreakable, but it is strong enough to keep liquids in these droplets. Now, we always seem to think, or a lot of times for me, I always think of water. I think of liquid, I think water, I think liquid, I think water. It doesn't have to be water, though, right? It could be other substances. I believe I showed some liquid mercury to a class once, which is a metal liquid. And the cohesion of a mercury droplet, and maybe I'll show this again tomorrow, is even stronger than water, right? It really wants to hold together. Whereas some other liquids, their cohesion might not be as strong. But anyhow, cohesion is this property that liquid particles, all liquids, attract to one another. They're not like gases where they're independent. They still kind of hold each other. Okay. Second term that we're going to talk about today is then surface tension. Now, this is related to cohesion. Um, at the surface of a liquid, you can imagine there is a spot where the liquid particles meet the air that is above them. Okay, because of cohesion, the liquid is attracting to itself much more than it is the air molecules that are above. And what this does is it creates a sort of a film. So surface tension is defined as and I'm going to put quotes around this. When I say film, I'm talking like a thin membrane that forms, okay, which forms, and I will show you a demo with this tomorrow if this doesn't make sense today. At the surface of a liquid. Best place that I could probably come up with an example of this is everybody I think has had the experience that you're near a stream or maybe a pond and you look down and there are these insects that are standing on the surface of the water. How do they do that? Well, they do that because of this surface tension, this film, right? There's actually this little, like I said, membrane that forms at the surface of a liquid because that's where the liquid meets the gas, and these insects can stand on it. And tomorrow in class, I can actually get a paper clip to kind of float on the surface tension of the water. So those insects, which I think most people have seen before, are called water striders. Okay, and they actually walk on, live their life on, scoot around on the surface tension in slow pools and streams or oops, surface tension or ponds. Walk around. Okay, just another footnote on surface tension is surface tension actually prevents water. Like when you use water to wash your clothes, for instance. The reason why we use water is because the water kind of carries the soap molecules and stuff into the fabric that's being washed, and it attaches itself to the dirt molecules, and then the water and the dirt are able to be removed from the clothes together. So when we do that, surface tension is actually not our friend, right? Because surface tension is going to hold the water together and not allow the water molecules to penetrate the fabric. So one of the things we do is we use chemicals known as detergents. And detergents do a couple of things, but one of the things they do is break surface tension. And I'll show you in this demo tomorrow that I do in class that surface tension between water molecules, when there is soap introduced, kind of breaks down. And this is good if you're washing clothes because it allows the sort of the water to penetrate into the fabric better and remove the dirt. That is what we're trying to do when we wash clothes, right? Okay, so again, I have some demos on surface tension, which certainly makes this a little easier to picture rather than just writing down words, but we'll do this today and we'll take care of that tomorrow. Okay, so moving along. Next term on the list that pertains to liquids is viscosity. Um, Most people have had an experience with viscosity when they have a honey jar, honey container, and you turn it upside down to allow it to go into your tea or whatever you're using the honey on. And you stand there and you bang on the bottom of the jar, et cetera, and the honey doesn't come out very fast. It takes a long time, right? That's the property of viscosity. So viscosity is simply defined as a liquid's resistance to flow. Basically, in layman's terms, we might say it's how easy something can be poured. Okay, and think about all the different liquids that you know. Some of them flow really easy. A glass of water is an example of something that you turn it over or turn it on its side and the water flows right out real fast. Okay, so we would say that has a low viscosity. Substances which can flow easily and quickly. Viscosity. Okay, so I would list maybe water, rubbing alcohol. I'm trying to think of some other things off the top of my head. Hydrogen peroxide has a low viscosity. Bleach, etc., etc. They flow easily. And on the other side of the spectrum, high viscosity would be things like honey. Maybe I could put down molasses. I'm not sure if you guys know what that is, but that is a byproduct of the sugar refining process. And it's used in recipes. It's an ingredient like in gingerbread. If you eat gingerbread, that is a food that has molasses in it. It's very dark in color, um, and used in some baking. So it is very thick also. Might say viscosity instead of viscosity. A lot of times we say thick. Okay, but anyhow, viscosity, liquid's resistance to flow. Remember, low means you can flow quickly. High means it takes a long time for it to flow. It resists flowing. And there's a video on viscosity. Make sure you watch it today, which shows viscosity races between different substances where they travel down a surface and they're able to compare. Now, there is one footnote to viscosity, is that even within a single substance, like let's say honey, viscosity can change. And what can make it change is temperature. So one of the tricks to getting honey to flow well is if you want it to come out of the jar quickly, you warm it up a little bit. Maybe you can do that in the microwave. Maybe you can do it by taking the container and just kind of submersing it in warm water. Um, if a substance is hot or warm, its viscosity is going to be lower. It's going to flow easier, so the viscosity goes down. If a substance is cold, then its viscosity is going to be higher. Um, Motor oil. I should mention this while I'm thinking of it. One of the substances that's actually labeled and sold based on its viscosity is motor oils. So there are all kinds of different grades of motor oil. You buy 10W30, 5W20, there's 10W40, etc., etc. And one of the differences between those oils is the viscosity. How thick it is, how easily it flows at different temperature ranges, etc., etc. And motor oil as well, when it gets hot, the viscosity is lower. It flows much more easily. And when it's cold, the viscosity is a lot higher. Okay, so viscosity, flowing. Last thing on liquids on today's notes is something known as hydraulics. Um, liquids are good substances to use in mechanical things. And the reason why is because they are not able to be compressed. So anytime that you try to squeeze a liquid, remember with gases, we talked about how gases can be compressed into smaller spaces under high pressure. Um, Liquids, you can't do that. They resist compression. So anytime that you apply a force to a liquid, that force gets transferred by that liquid to all the surfaces with which the liquid is in contact. And this is going to be one of those ones that's difficult for me to um, kind of describe here just with words. And I'm going to have to show you some demos tomorrow, but maybe I can give you a couple ideas of things that are hydraulic devices. You've probably, it seems like when I ask the question, has anybody ever heard of hydraulics? Everybody in my eighth grade classes seems to come up with lowriders and those cars where they have the hydraulic suspensions and they kind of go up and down and stuff like that. And those are indeed hydraulic systems. Okay. The reason why hydraulics work is because liquids are incompressible. They can't squeeze them into smaller spaces. Um, some other places where you might see hydraulics. If you look at tractors, one of the devices on a tractor is called a front end loader, right? That's the big bucket, that kind of long rectangular bucket that you might see some people removing snow with, or moving materials around. All the movements of those buckets, on the sides, you might see those like pistons that move around, and the bucket can kind of tilt up and down. And of course, it can go up and down the whole thing completely. It's got a couple angles that it can move, and that's all controlled by hydraulics. Also, when you drive your car, think about it. You're going down the road in your car going 70 miles an hour, and you push on this little pedal there in the driver's um, well, and it causes the automobile to stop. Whoops. And you might not think twice about that, but it's kind of remarkable that that happens. And that's done with hydraulics also. Okay. And what it is brake fluid, right? That's a liquid brake fluid that's in this system. And when you push the pedal, essentially what happens is the force that you apply to the pedal gets distributed to your brakes. And that same force then can be applied, causing the brake pads and the rotors to kind of come together and create friction and cause the car to stop. And that's all done using liquids. That force is transferred through liquids. One of the cool things about hydraulics is not only can a force be transferred through a liquid, it can also be multiplied through a liquid. So there are hydraulic devices, like there are little car jacks that I can use in my garage, and I can lift my truck up in the air using just my hands. Now, I can't do that on my own, so something about what that jack does. And there's no magic. The jack isn't plugged in. It's not taking in energy from elsewhere. It simply is able to multiply the force that I can input and allow me to, really be stronger than I am. And again, hydraulics is one of those things. It's going to be difficult for me to give you a picture of it here, just talking about it. So I'm going to give you the notes for today, and I promise tomorrow in class that we will mention hydraulics. Okay, so that's it. And again, I apologize. This is not ideal that I don't have my demos to do as I explain these things. But again, we'll do the best we can with the situation we're given. So please take these notes today. Again, if you can print this out and have it filled out when you come to class tomorrow, um, This is attached, by the way, to your notes. This is something actually that you can do. Perhaps, I don't know if you're going to have eyedroppers at home, but if you want to look at that, I think you might have done that lab in sixth grade too. I know some students have said that, but it's like how many droplets you can get on a penny because of cohesion, right? You can pile water droplet. You lay a penny on the table, you can pile water. Anyhow, that's there. Don't worry about it. If it's not something you can do, it's not that important. I didn't realize it was attached to this document. Okay, so please watch this, take these notes, print this out if you can. Go watch the videos in the Schoology folder on viscosity and on properties of liquids. And I will see you tomorrow. Have a great day.